There we go. Clip on there. Okay, good morning, everybody. I won't start the content until we actually hit 9 o'clock, which is rolling up pretty soon. Just want to give a general heads up. I don't know if you saw the weekly announcement email that I sent out yesterday. You'll be receiving weekly announcements from me each weekend, just with updates on like what the hell's going on, what are we doing, how is this proceeding, so on. Obviously, if you receive communications directly from the university, which no doubt you have and will continue to, that will supersede anything I tell you. It is not up to me whether or not this class runs and meets. That is up to the university, so you will probably hear the same time I do, if and when they get around to canceling this, the actual in-person meeting. In the meantime, this lecture's all being recorded. Live streaming technology has not worked very well in past semesters. I doubt they're going to work it out now. But it should all be recorded and available for you to watch afterwards. So that'll be fine, no problem. I'm going to use the document camera here extensively in terms of providing the visual, and that should all be captured as well and recorded too and made available for you. There is no attendance requirement. There is no participation requirement for this sort of thing. So it is up to you to deal with where you choose to put yourself, where you choose to be, and how you choose to approach the virus situation. Myself, if I weren't required to be here by my job, I wouldn't be here. And I think it's kind of silly of you all to be here unless you have particular circumstances that I don't know about. But that's for you to decide. I will do everything possible to make the class as approachable and as available to you in a remote fashion. With that in mind, let me flag, again, I know a number of you have already seen this and a number of you are already participating on this, but let me flag again to you the site Perusal, which is a site where you get all your readings for this unit, where you get all those, all the content and exercises. That also facilitates questions, discussions in the margin. There are already questions and discussions in the margin up and rolling on at least the first 3 readings over there in Perusal, and I'll be continuing to monitor that regularly, and feel free to help each other out and discuss there. That's something that can obviously not replace in-person meetings, but it can provide some of the good of a discussion that we might struggle to get a bit face-to-face this semester as things play out. So that's just heads up, that in mind. Let's dive right in and take a look at the content, because this week, week 2, conjunction week, is a week that's going to set the pattern for our next several weeks in terms of the content we're looking at. So what we're going to do in weeks 2, 3, 4, and 5 of the semester, each week we're going to meet some new connective or connectives, and we're going to learn the same things about each connective or connectives. So for each connective, we're going to look at 4 ways of dealing with the connective. Each connective is going to have introduction and elimination rules. And rules make it sound like they're about what you can't do, but rules in this context, rules in the context of our proof system, are about what you can do. Rules are building blocks, right? Your proofs are things that you're going to be building up out of components, and those components are the rules. So the rules are enabling rules. The more rules you have, the more you will be able to do, because the broader a variety of building blocks you'll have. That's why we're going connective by connective and introducing them piecemeal, because the full system, it's not unbelievable. Well, in some sense, it is unbelievably complex. It's not like mind-blowingly complex. You'll be able to handle the full system, but it's easier to build up to piece by piece, get used to a couple pieces at a time. So for each connective, you're going to get these rules, and these rules will allow you to build more and more complex proofs as you get more and more of them. Then we're also going to look at I'm going to call a reduction procedure, and this is a way of transforming proofs. And we'll think a little bit about what that transformation is, what that means, what the nature of it is. But the idea is you'll be able to build up, using your rules, you'll be able to build up complex proofs of various sorts, and some of these proofs will be candidates for going through a reduction procedure. And if they go through a reduction procedure, what results is a different proof, right? So some proofs are ready to change into other proofs. And we'll call reduction that kind of change. So your rules allow you to build a proof, and your reduction procedure takes you from one proof to another. And for each connective we look at, we're going to get introduction rule, elimination rule. We'll see in a second why they're called introduction and elimination. But for each connective we look at, we're going to get introduction rules, elimination rules, and a reduction procedure that allows us to transform a proof in a way that's based around that connective, in a way that's based around what that connective means. And we'll also look, but this is going to be far less important for us, at a thing called expansion, which is, it's a lot simpler than reduction. In some ways, it's the opposite of reduction, but it doesn't. Anyway, the notes go over it. I probably won't look at it much in the lecture. I don't think you have any exercises on expansion through the course of the semester. Maybe you just have one or two of the big exercises touch on it. It's not a main topic for us, but it is there in the notes if you want to take a look at it. So this is going to be the pattern for each connective. We're going to focus primarily on introduction and elimination, make sure you get to build those proofs, and then look at how reduction gets you to change one proof into another. With leftover time, I'll mention expansion. Okay, for now, that's just a whole giant mess of jargon. If you're looking up at that and you're saying that's a giant mess of jargon, what the hell is Dave talking about? Yeah, that's an appropriate response to that mess of jargon. The idea is that as we move forward, that mess of jargon will become more familiar, more intelligible. By the end of week 5, you'll be like, yeah, introduction, elimination rules, right. Okay, next connective, come on, what is it? But for now, we just need to learn a little bit about what these things mean and how they operate. So the connective we're looking at this week will be, there's a reason we're starting with it anyway. I don't know how to measure simplicity. In some sense, it's the simplest. Maybe it's not the very simplest, but like, if you get any simpler, it gets kind of hard to see something because it gets so small and simple. So anyway, it's probably the easiest one to understand. At first, it's a connective that we're going to be calling conjunction. And it's written like that. It's a little hat, or a caret, or a wedge, or whatever you want to call it. And it combines two sentences together to make a larger sentence. We looked at forming sentences in that first week content. So we saw sentences like P and Q, or P and Q and S and T and P, or things like that, right? Whenever you have two sentences, you can put them together with a conjunction. That is, you put them on either side of the conjunction, and you've made a new, bigger sentence. And you can continue to do that as much as you want, right? So this whole thing here, this is all one sentence. And the parentheses just tell you how it was put together and combined. So this has 1, 2, 3, 4 different conjunctions in it. Just quick review from the first week's stuff. Which of those 4 conjunctions is the main connective of that sentence? Yeah. Absolutely. Why is that? That's it. It's dead on. What's your name? Brandon? So Brandon's got it dead on, right? It's that final 4th conjunction that's the main connective, and it's because it's the one that stands outside the parentheses. As long as you make sure you're using parentheses appropriately when you build your formula, as long as you make sure that everything is nice and unambiguous and you don't ram too much stuff together, that is, each connective like conjunction or implication has one thing on each side and that's it, then it'll always be easy to find the main connective. It'll just be the one that's outside all the parentheses. So in this case, the main connective is that one. So that's going to be we're going to need to start using some of that main connective vocabulary today. Another pair of pieces of vocabulary from the first week would be good to review because we'll need to use those today. In this sentence, in this conjunction, right, it's a conjunction of 2 sentences together. Does anyone remember the name for the sentences in those positions? Take this P on the right, for example. Anyone recall what that's called? Yeah. The P is an atomic sentence. Absolutely. That's definitely right. Or an atom. You can call it an atom. You can call it an atomic sentence. That's dead on. That is, my question was ambiguous. That's not the answer I was fishing for, but that's on me. You're absolutely right. The P is definitely an atom in this case. What's your name?
Tom.
Tom. Thanks very much, Tom. That's dead right. Maybe let's look at this left one, this whole mess. What relation does that left mess have to the whole sentence of which it's a part? Yeah, I'm not fishing very effectively. It absolutely is a complex sentence. See, this is why it's a sign that I'm not fishing very effectively, because you're all saying absolutely true and correct things that totally answer the question that I'm putting into words, even though it's not what I'm fishing for. But that's on me. Yes, that's the one I'm fishing for. Absolutely. These are the conjuncts of the conjunction. Yeah. Oh, what's your name? Tabby? So Tabby's got it absolutely right. These are the conjuncts of the conjunction. And every conjunction has two conjuncts. It has a left conjunct and a right conjunct. And the left one's the one on the left and the right one's the one on the right. That telling left from right can be hard, but telling your left conjunct from your right conjunct is no harder than telling your left from your right in general is. Left conjunct's the one on the left, right conjunct's the one on the right. So we're going to need to think today as we look at our rules about which sentences have conjunction as their main connective, and of those sentences, what's the left conjunct and what's the right conjunct. That's all vocabulary that would be useful to have. Okay. So far, you've got only one rule that is, in week one, you've got only one rule that allows you to form a proof. And for most of the unit, there will be some exceptions to this later, but for most of the unit, this is going to be the only rule you have that allows you to build a proof from nothing. It's your starting place rule. And the starting place rule for any proof is your rule of assumption that we looked at in the lecture one video, right? So you just write down any sentence at all, and you've assumed the sentence. You should think of this as saying, like, suppose blah, right? So I could start a proof by saying, suppose P. And you can suppose, this rule of assumption allows you to assume absolutely anything you like, right? We're going to think about what would follow from P, right? If we just take P for granted, what comes from it? That's what the rule of assumption allows you to do. Our other rules, again, there will be exceptions later, but minor exceptions. In general, this is the way to think of it. Our other rules, besides the rule of assumption, all tell us how to extend proofs that we already have. Right? If you want to get on the board at all, you need to make an assumption. Once you're on the board, you can extend and combine things together and put them together using these other rules. These other rules allow us to build more complex proofs. So first rule we're going to look at today is the rule of conjunction introduction. And it looks like this. This is the schematic form of it. Now let me tell you what this means. Whenever you see stuff above a line and below a line like that, that's telling you that you can put your proofs together in this sort of way. It means if you have proofs of what's above the line, you can extend those proofs with an application of this rule and get a proof of what's below the line. Right? So proofs always grow from the bottom. They grow downwards. So in this case, for any sentence A and any sentence B, if you have yourself a proof of A and you have yourself a proof of B, then you can combine those proofs with this rule of conjunction introduction and get a proof of a new sentence. That sentence is the conjunction whose left conjunct is A and whose right conjunct is B. Right. So this is This is a rule that allows us to grow new proofs from old. In particular, if we have a pair of proofs, this allows us to put that pair together into one proof of a new thing. Simplest kind of case of this rule, for example, would be something like this. Here's an example. So this is a full proof here. Right? We started with a proof of P by assuming it. So that's a proof of P with the open assumption P. We also started with a proof of S, again, just by assuming it. So that's a proof of S with the open assumption S. So now we've got two proofs. We've got a proof of P and we've got a proof of S. And so we can put them together with this rule of conjunction introduction, just like so. Now we've got a proof of P and S. There's a proof of this conjunction. And the open assumptions of that proof are P and S. Right? So the new proof that we've built inherits all the open assumptions that come into it, any component of it, right? If any assumption is open in the left-hand proof, it's also open in the final proof. If any assumption is open in the right-hand proof, it's also open in the final proof, right? So we have proof of P with open assumption P, proof of S with open assumption S, put them together with the conjunction introduction. Now we've got a proof of P and S with two open assumptions. One of them is P and the other one is S. Does that make sense at all? I know for those of you watching at home, you're probably going, no, that makes no sense. Sorry, ask on perusal. But for those of you here in the room, does that make sense? Is there anything I can do to clarify that more? Totally. So this is going to be, until we get to week 7, you're going to have to trust me on this. But here's the deal. Whenever you put together a proof, part of what it is to put it together correctly is labeling each step that you've put together with what step it is. So the rule of assumption you don't have to label. That's the only one you don't have to label. The rule of assumption, you just write the formula down and there it is. But every other rule, you have to mark which rule it is. For most things that you're doing, for example, for this thing that you're doing, there really is, even once we have the whole full system in view, there's no other rule that could be. If you're going from a P and an S to a P and S, it's got to be conjunction introduction. But it's not always like that. There are other rules. In fact, the rules of conjunction elimination that we're going to look at later today, we'll give an example, and I'll try to remember to return to this, where you could make the very same transition. Two different rules might allow the same transition, and that difference is actually going to turn out to matter, although that's the thing that we won't see why it matters until week 7. But it's important to label each step because we will later need to be able to look at them and know which step each step is, which kind of step each step is.
So is the I the label?
Yep. So this is a rule of conjunction introduction, and so the I just stands for introduction. So you see the label here has the conjunction as well as the I. So that just means conjunction introduction. So each connective is going to have introduction rules and elimination rules. And we'll use the connective and I to mean the introduction rule. This is the conjunction introduction rule. And as we'll get to in a moment, we're going to use E, no big surprise, for the elimination rules. So all our rules, other than the rule of assumption, and this doesn't have exceptions. All our rules, other than our rule of assumption, are either an introduction rule for some connective or an elimination rule for some connective. So all our rules will have names like that, except for the rule of assumption. So this is the kind of start of a grand pattern that will occupy us for the first month or so.
Is the main connective then between the two sentences below one?
Yes, the main it's sentences that have main connectives. So this sentence's main connective is right there. This here is just a label. It's not there. Yeah, so all our introduction rules, what makes this an introduction rule is that it tells us how to build up a sentence with the connective in question as its main connective. All our introduction rules do that. Right? So if you see the result of conjunction introduction is a sentence that has conjunction as its main connective. That's what makes it an introduction rule, right? Whenever you apply conjunction introduction, you always get a sentence with conjunction as its main connective. This tells you how to introduce a conjunction into the proof. You might already have some conjunction somewhere else in the proof, right? Because you can put together any two proofs with this rule, but you're introducing a new conjunction whenever you apply this rule. So we can look at a more complex example here. We can take